Hey everyone, and welcome. Today we're going to take an ordinary plastic bottle and turn it into something amazing, a powerful little scientific tool. So let's get started and build our very own water filter, right from scratch.
Have you ever really thought about it? You see a muddy puddle on the sidewalk, then you go inside and get a perfectly clear glass of water from the tap. What in the world happens in between? Well, it's not magic, it's science.
And you know what the best part is? You can do this right at home. We're about to put together a miniature water purification system that pulls back the curtain on the exact same principles used all over the world.
All right, first things first, let's get our little at-home lab set up. And trust me, you are going to be surprised at how simple and common these materials are.
So here's our shopping list. A plastic bottle, some sand and gravel, which you can probably find at any garden store, and our secret ingredient, activated charcoal. You'll often find that sold for aquariums. And of course, some protective gear. That's it.
Okay, now before we even think about building, we have to talk safety. This is a hands-on experiment, so you've got to put on those gloves and goggles. It's a non-negotiable step in any good scientific work, right? And here is the most important point of the entire day. I need to be crystal clear about this. This filter is going to make dirty water look clean, but it is for observation only. It is absolutely not designed to make water safe to drink. This is a visual demo, not a survival tool. Okay? Now for the really fun part, building this thing. The genius of this design isn't in any single material, but in how we arrange them. The secret is all in the layers.
We're building this from the bottom up. So the coarse gravel at the bottom acts like a bouncer. It catches all the biggest particles. Then the sand comes in and snags the smaller bits. After that, the charcoal works its special magic and the top layers give it a final polish. Each layer has a very specific job to do.
So, our filter is built, the layers are all set. Are you ready for the moment of truth? It is time to see if our simple little device can actually do the job. Now, the key here is to pour slowly. Give the water time to trickle down and really interact with each layer. Watch closely as that murky water begins its journey, and just see what comes out the other side. You are watching filtration happen in real time.
Okay, so seeing it work is one thing, but understanding why it works, well, that's where the real aha moment happens. So what is the science behind this pretty amazing transformation?
At its heart, what we're doing is called filtration. And you can think of it like a really complex kitchen sieve. Each layer has different sized gaps, or pores, and as the water passes through, these layers physically block and trap all the suspended stuff from big pieces of grit down to the finest sediment. But there are actually two totally different things happening here. First, there's the filtration, that physical trapping of solids we just talked about. But then you have absorption. This is where that activated charcoal is the star of the show. Its surface doesn't just block things, it chemically grabs onto tiny dissolved impurities and even gets rid of odors that the sand and gravel just can't catch.
So we made some clear water in a bottle. That's a great experiment. But what's the bigger picture? How does this little home project actually connect to the real world?
Believe it or not, the device you just built operates on the exact same principles as the massive water treatment plants that supply clean water to entire cities. They use huge beds of sand, gravel, and carbon, just on a much larger scale. So you see, this isn't just a science experiment, it's a lesson in engineering. You've been thinking like an engineer, using different materials with distinct properties to design a practical solution to a very real problem, getting clean water. And that's exactly why this matters. This simple, fundamental principle of layered filtration is a cornerstone of public health. It's a technology that makes fresh water safer and more accessible for countless people around the globe every single day. So as we finish up, I'll leave you with this thought. We took a bottle, some sand, and some gravel, and we modeled the technology that saves lives. It really makes you wonder, doesn't it? What other world-changing solutions are just waiting to be discovered with a small, simple experiment?